Welcome to Sundar's lecture. This is lecture number 4, and in this lecture we are going to see the third part, decimal to any radix, conversion of decimal to any radix. See, we have not taken the second one. I will explain you a bit later. See, what are all the topics we have seen in the previous class. See, we have started with the conversion involving binary, right? This is the types of conversions, and we have started here conversions involving binary, and we have taken all the things, right? Octal to binary, binary to hexadecimal, and then we have gone for hexadecimal to binary, and then we have came to octal to hexadecimal. Here we have uh, studied that we cannot directly convert octal numbers into hexadecimal. That for that we need to convert octal to binary and then binary to hexadecimal. The vice versa is also the same thing. Hexadecimal to octal, you cannot convert directly hexadecimal to octal. So what we have done, we have converted hexadecimal to binary and then binary to octal. And we have given this question in the previous class, and I have asked you to solve by yourself. See, today I will do it for you. See, this is the question, right? So what we need to do, we have to convert this hexadecimal to octal. For that, what we need to do, you have to convert this to binary now. So I am not going to do procedure, everything we have already studied. So I can directly write it now. So how I can do that? So this one, what is the equivalent of A? What is the equivalent of A? It will be 1010. Directly I am just writing. So this is 1011. Sorry, this is 1011. So this will be 100. 1100. You just verify. I am just writing directly. And then for B, it will be 1011. That is a dot. You put a dot here. And then for C, again, it will be 1100. And then for 1, it will be 0001. That's all. So now we have converted this by hexadecimal to binary numbers, to binary digits, maybe binary digits. And then we have to convert this binary to now octal. So what we need to do, we have to just split this number into 3. From this point, we have to go 1, 2, 3 here, 1, 2, 3 here, 1, 2, 3. You have to put a line here. That's all. We have 3 digits here, and then here you put this one. You put this one. 1, 2, 3. Put 1, 2, 3. Put a slash. 1, 2. Just 2 numbers are there. Add 1 extra 0. That's all. You just try to write the numbers now. So 0, 1, 1, it will be 3, and then 0, 0, 1, it will be 1, 0, 1, 1, again it is 3, 1, 0, 1, it is 5, and then 1, 1, 0, right? So 1, 0, 1, and then 1, 1, 10, so it will be 6, it will be 6, then it will be 0, 0, 1, 0, it is 10, right? 0, 0, 0, 1, 2, it will be 2. So this is the final answer. So we have converted. This is binary value 5. Sorry, this is octal value 5313, and there is a point here, 0.602 at the base of 8. At the base of 8. So what we have done, we have converted this hexadecimal number into the octal number. That's all. This is the procedure. Okay, fine. Now we will go to the next topic, that is decimal to any radix. For example, they have given you any decimal number, any decimal number, any decimal number, any decimal number, and it is base 10. See, for decimals, we generally don't put this base value. If they have given you 58, convert that into a binary, then you have to directly understand that that is the decimal number, right? So anyhow, so for to any radix, so for to a base of 2, or for base of 8, or for base of 16, all the procedures are same. Try to understand. You have to change this base values only. But the procedure for converting this decimal to any radix is same for all things. Same for all the other radix. You have to change the base values. Anyhow, I will write it down. See, there are two ways to convert this decimal. Not two ways. If you have any fractional values, then you have to do separately for integer values and you have to do separately for the fraction digits, right? So what we need to do now, I will just write it down for integer, for integer, for integer. I will give you examples so that you can easily understand. So for integer, you have to go for successive successive division, successive division method, successive division method. And for the fraction values, for the fractions, you have to go for successive multiplication, multiplication method. These two methods will help you, right? So what I will do, first I will explain you these two methods and then I will consolidate and I will give you the data finally what we need to do for integer and what we need to do for fraction methods, right? So what we do now, straight away we will take an example and we try to convert that decimal number into any radix. First we will take an example. See, this is the first question and we have taken the first option to convert decimal to binary number, and this is the question. So straight away there is I have not taken any fractional values. I have just taken the only integer part, direct question, right? Whole number, right? So 16, that is the base 10. You have to convert this into the binary value. So what you do, see, we generally put this value 16 we will directly take. So for the integer part, you have to go for successive division method. So what you do, you just divide by the base, this base. Divide this by 2 and you will have two things. One is quotient and one is remainder, right? One is quotient and one is remainder. And what you do, if you divide these two, 16 divided by 2, what you will get? You will get obviously 8 and there will not be any remainder. So it will be 0. And you have to take this 8 to the next part. You have to take this to the next part, and then you have to write this, you have to take this 8 divided by, again you have to make this to 2 because the base is 2. We are converting the decimal number to binary. That is the whole idea. And if you divide these two, again you will get 4 here. This is 4 and there is no remainder, right? So straight away you put 0. And again you have to take this part, take only this part to the next one, and this is 4 divided by 2, and again you will get quotient as 2 and there will not be any remainder, put 2, put 0, and you have to take this to the next part. This is 2 divided by 2, right? And 2 divided by 2 you will get obviously 1, and there is no remainder. See, you cannot divide this 1 to the next value because 1 cannot be divided by 2. So you have to stop here. This is the final point. We will take some more examples like converting decimal to octal. There you cannot, for octal we will divide it by 8. So if 7 comes, then you have to stop there. So what is the answer here? So you have to go in this way. You have to write the answers. Why I am doing this? So this is the first value. So 1, this is the second value, 0, third, and then you have to write like this. 1, 2, 3 zeros are there. 1, 2, 3, 4 zeros are there. So we have converted. This is the whole idea. See, generally this is the final answer also. So generally what we will write, this is M, S, B, and this is L, S, B. We generally write like this. Most significant bit, least significant bit, and this is MSB and this is LSB. This is the final answer. So always what you do, you just write from here. So this is the first, that this is the most significant bit and this is the least significant. Maybe M is the most significant digit or least significant digit. There are so many notations are there, but we will generally use MSB, LSB, right? So now this is the successive multiplication method to convert the decimal number into binary. Here we have done for binary. So what we will do now, we will take with fractional numbers. That means, for example, we have an example like this. See here, this is the question and you have to convert this 12.125 at the base of 10, this decimal value, into binary number, equivalent binary number, right? So now you see, we have separate integer part and then separate fractional part. Then you have to follow both methods. First, we will go for the successive division method, successive division, successive division. So if successive division method, then you have to take the this integer part alone, this integer part alone, right? Method. So we will take that. So what we will do now, we have to take this 12, we have to take this 12, 12, and we generally write this one, right? So this is quotient and this is remainder, this is remainder, right? So you have to divide this by 2, right? So I will straight away write, we don't need to take so much of time. So 12 divided by 2, so quotient will be 6 and remainder will be 0, and then you have to take this 6 again, 6 divided by 2, the quotient will be 3 and then this remainder will be 0, and then you see here 3 divided by 2, you have to take this 3 here, 3 divided by 2, and this value, if you divide these two, the quotient will be 1, right? The quotient will be 1 and the remainder will be also 1, remainder will be also 1, right? You have to understand this one. See, you cannot take this quotient 1 divided by 2, it is not possible. Try to understand. 1, you cannot divide 1 by 2, it becomes now the fraction value. So you don't go, you don't do that. So now this is the final answer. You have to go in this way, in this way. So what is this one? This is MSB and this value will be LSB, most significant bit and least significant bit. So this is 1 1 0 0 at the base of 2 for this value, only for this 12, that is the integer value. And what we need to do, we have to go for successive multiplication also, successive multiplication. See, you have to be very careful here. Multiplication method. So in successive multiplication method, what you have to take, only this in fraction part. That means you have to take like this 0.125. You have to take like this 0.125, only the fraction value. And here successive multiplication method, what you do, you have to multiply this by 2. You have to multiply this by 2. So if you multiply this by 2, see, I am getting it to be 0.25, 0.25. See this one, you have to be very careful. This you have to take it as the answer. You have to take this value has to be the answer, and this value, right, 0.25, and you have to bring this value down here. This has to come here. That means you have to multiply 0.25. Why I am multiplying it by 2? Because I am converting this to binary number. That is why I am multiplying it by 2. You have to be very careful. And this value has to be multiplied by 2. And what you will get now, this value, if you multiply this one, you will get 0.50. 0.50. That is the thing. And the answer, you have to take this to be the answer value, this to be the answer value, and you have to take this 0.25, sorry, 0.5 to the next part, and what you will get now, if I multiply 0.5 multiplication of 2, and what I will get here, this will be 1.00, and this has to be the answer, and this has to be the answer, and this 000 has to be taken to the next one. What it will come, it will be again 0, so you have to stop here. This is the final point, but in general we don't go for successive multiplication for so many digits. You can stop by 2 or 3 digits, that is mostly enough, but anyhow we have got the final answer here, because 0 cannot be multiplied. 0.00 multiplied by 2, it will be again 0, so you don't need to go here, right? So but here, see here very carefully, this is the most significant bit here. You have to take this as most significant bit, and this value has to be least significant bit. So what you have to write here, this value has to, you have to write as a most significant bit 0, 0, 1. You have to write like this, right? So now the final answer will be 12.125 at the base of 10 can be written as 1100.001 at the base of 2. Now this is the final answer. This is the final answer. This is successive division method, and this is successive multiplication method, right? So what we will do, this is the same procedure. You have to follow the same procedure for all other conversions, right? So what we will do, we will take an example for binary to, sorry, decimal to octal now. See, this is the question they have given you. See, I'm not taking only the integer examples, because that is very simple. You can do it by yourself. But what I have to do here, I have to take with the fractional value, so that you can easily understand. If they have given you only the integer part, then this part alone comes. This part, for example, they have given you 12, then this is the final answer, right? So I will go for the hardest part, not even hardest part. Anyhow, I will take the examples with the fractional part, right? So now you have to convert this value, that means 658.825 at the base of 10 maybe decimal number, to the octal value. So the procedure, again you have to go for successive division method and successive multiplication method. Why? Because you have a fractional values, right? So I will go very fast now, not I'm not going to take much time. So this will be 658, and then this quotient will be there, and then remainder will be there, right? So if you divide this by 8, because why I am dividing it by 8, because this is the octal value. So if I divide this by 8, I am getting it to be 82, and then remainder will be 2 here, and I have to take this 82, that I have to divide it by 8, and I am getting this to be 10, and the remainder will be 2, and 10 divided by 8, so I am getting 1 as the quotient and 2 as the remainder. I cannot divide this 1 by 8 now, so this is the answer, final answer. So what you do, this one is the most significant bit, and this one is the least significant bit. So the value will be 1222. That's all. This is the value. And I have to go for the successive multiplication method for this one. So this will be 0.825 multiplication of 8 now. Multiplication of 8. So if I multiply that by 8, I will get 6.6, and then what you have to do here, you see, you have to be very careful. This 6 has to be taken out. This is the LSB bit. This is the most significant bit. And you have to take this 0.6 now out from here. So it will be 0.6 multiplication of 8 will come. So what I'm getting for this one, this is 4.8, and you have to take this 4 out. This 4 out. This is the answer. This is the answer part, and this 0.8 has to be taken again outside. So this will be 0.8 multiplication of 8. So if I do so, I am getting 6.4. I am getting 6. See, one thing I am telling you again. So you stop here. 3 digits, it is mostly enough. mostly enough. Don't go again 0.4 into 8 because it will be going down, going down. So you just stop here and you write this as now LSB, LSB. So the answer will be, what is the MSB? This is 646. That's all. And the base of 8, not exactly. This is actually, you have point here. So the final answer will be what? So 658.825 at the base of 16 is equivalent to 1222.646 at the base of 8. This is the final answer, right? So, sorry, not 16. This is 10, right? This is 10. This is 10. Right. This is the final answer. And we will take another example. See this one, the next one will be decimal to hexadecimal. We have taken a decimal value and we have to convert that into the hexadecimal. See, again, I am not taking only the integer values because the same thing, the procedure will be same. The successive division method. So, we have fraction value here. So, what we need to do, we have to take this 5, 3, 8, 6 and we need to divide this one by 16 now. 16, that's all. The 16 and you have a quotient here and then you have a remainder here. So if I do so, if I divide this one, I will get it to be 336, and the remainder will be 10, and you have to take this 336 and you have to divide this one by 16, and if you do so, I am getting it to be 21, the remainder will be 0. Again, you have to take this 21, you have to divide it by 16. So the value I am getting it to be 1, right? Because 1, it will be 5. And you cannot further divide this 1 by 16. It won't come, right? The whole number will not come. So the final answer can be written like this: 150. What is 10? That is very important because you cannot put 10 directly here because you have to write it as what? A. 150 A. Try to understand. You have to write like A because the equivalent 10 in hexadecimal, it will be A, right? So this is the answer. So this is nothing but MSB, most significant bit, and this is least significant bit. See, always we will write most significant bit in the left hand side and the least significant bit in the right hand side. I have to tell that too. This will be always MSB. We always call this as MSB and we always call this as LSB. Always. We generally write that, right? So next one, what we have to do, you have to convert this 0.345 in successive multiplication method. So what you do, you just multiply this by 16 now because this is conversion of decimal to hexadecimal. So you have to multiply it by 16. So if I do so, I am getting 5.52, and you have to take this value out, you have to take this value out, and the next part, what is the next part? You have to multiply this 0.52. Only you have to take 0.52, not 5.52. Try to understand. This value already taken out, so I have to take 0.52. Multiplication of 16, and I am getting it to be 8.32. And I have to take this 0.32 again, multiplication of 16, and if I do so, I am getting 5.12, and I am taking extra one time 0.12 multiplication of 16, I am getting it to be 1.92, and if you are doing it again and again, it will come down. So you don't do 3 digits, maximum 3 or 4 digits, you stop there, right? So this part, this will be most significant bit, and this part you have to take it as least significant bit. So the value will be what now? So 5, this one, and then this value 8, this is 5, and this is 1. You have to take in this way, from most significant bit to least significant bit. You have to write like from most significant bit to least significant bit, right? So now what is the final answer? What is the final answer? It is 5386.345 at the base of 10 can be written as what? 150a, the integer part, point this value 5851 at the base of 16. So we have converted the decimal value into the equivalent hexadecimal value. See the next part, it is any radix to decimal. See what we have done now. What we have done, see here we have taken all the values, right? So decimal to any radix. So you have to convert decimal to binary. That is what we have done here, decimal to binary. And then decimal to, we have taken another example here. So decimal to octal, we have converted. Decimal to hexadecimal, we have converted. Everything has been completed. Now this one, any radix to decimal, which means the base of 2 has to be converted into equivalent decimal value, and then the base of 8 should be converted into the equivalent decimal value, and then base of 16, that means hexadecimal, the value has to be converted into equivalent decimal value. This is the procedure, and this procedure we have already seen. I told you in my first class. See here what we have done here. We have taken this one. See here what we have done. This is the binary. This binary value has been converted into decimal here. So this is the binary, and this binary has been converted into decimal. This is the first part, and you see here this one. This octal value has been converted into decimal by this procedure, and then again hexadecimal. This hexadecimal value has been converted into decimal value by this procedure. The procedure is same, and we have taken for an example. For example, what is the base 16, what is base 8, and what is base 2. While studying that, we have already seen the procedure of conversion to the decimal value. So you follow this procedure, same procedure. I have already told you, right? So follow my first lecture. Follow my lecture number 1 to get this procedures. So now we can conclude. So you see here, this is the part we have taken for the conversion. For the conversion, types of conversions involving binary. So in involving binary, what we have seen, we have converted binary to octal, binary to hexadecimal, and hexadecimal to binary, octal to binary, and octal to hexadecimal, hexadecimal to octal. We have to convert by converting the values of hexadecimal to binary and then to octal. As well as from octal to hexadecimal, you have to convert octal to binary and then binary to hexadecimal. That is what I have commonly written. The procedure will be same, whatever it may be. For involving binary, the procedure is same, single procedure. What we have done here, we have followed that one. And for any radix to decimal, that is what I have told you in the first lecture. And for decimal to any radix, that is what we have seen today. So what are all the topics we have seen in this particular lecture? In today's lecture, we have taken decimal to any radix, and the procedure will be successive division method and successive multiplication method. What does successive division method? You have to divide the decimal value by the base of which number you are going to convert, and you divide this one, take quotient separately, and quotient has to be divided successively. Successive division has to be done for the quotient, and remainder will be taken as the answer. And for successive multiplication, we have taken the fractional values here. So for successive multiplication, what you have to take? You have to take this value and multiply it by the base value. And that multiplication, you have to take this as the answer, and this has to be again successive multiplication has to be done for this particular values. And we have concluded, right? This is what we have seen in the today's class. In the next class, we will take the binary expressions, right? Binary expressions are we will generally call Boolean expressions. Not binary expressions, Boolean expressions. That we will see in the next class. What is the Boolean expression and how we are going to convert those kind of things we will see in the next class. Thank you.